Today, we're going to unravel a locked room mystery of physics that is literally nearly 2 centuries old. And let me tell you, it's a puzzle so completely counterintuitive, it's going to challenge absolutely everything you think you know about motion, invisible forces, and just how the physical universe actually operates. I am so thrilled to walk you through this because honestly, there is nothing quite like a paradox to really stretch the mind. We're going to look at a scenario that seems to completely break the fundamental laws of science. But stick with me, because by the end of our time together, you're going to see the beautiful, hidden logic underneath the whole shebang. Okay, let's dive into this. Can a spinning magnet sit perfectly still? Now, your immediate instinct is probably to say, well, no way, if it's spinning, it's moving, right? But what if I told you that a physically moving, rotating object could possess an invisible presence that remains completely, perfectly stationary? It sounds like magic. Or, maybe a riddle, but it is a hard scientific reality that has absolutely baffled students and even seasoned physicists for generations. To understand exactly why this is so mind-bending, we first need to quickly establish the ground rules of the physical world we're dealing with. All right, let's establish our baseline. This is electromagnetic induction. Discovered by the legendary Michael Faraday way back in 1831, this is basically the golden rule of how we generate electricity. The rule is simple. If you take a conductive material, like a copper wire or a disc, and you move it through a magnetic field, you get an electrical current. Conversely, if you keep that copper completely perfectly still and you move the magnetic field past it, you also get an electrical current. See, it's all about relative motion. One thing moves relative to the other, the invisible lines of magnetic force are cut, and boom, electrons start flowing. We literally rely on this exact principle for almost all the power on Earth, from massive wind turbines to the tiny alternator in your car. It is an undeniable law. So what on earth happens when we try to break it? Section 1. The crime against logic. Let's set the stage for our experiment. To really picture this crime against logic, I want you to imagine a flat, circular disc made of highly conductive copper. Right underneath it, perfectly aligned on a central axis, is a cylindrical magnet of the exact same size. They can both spin around, kind of like a record on a turntable. Let's walk through the matrix of what happens when we start spinning things. Look at the first row there. If we hold the magnet completely still and only spin the copper disc, an electrical current flows. Okay, this makes perfect sense, right? The disc is moving through the stationary magnetic field. We're cutting those invisible lines of force. Now skip down to the third row. We spin both the magnet and the copper disc together at the exact same speed. Bizarrely, a current still flows. Just think about that for a second. If they're moving together, locked at the same speed, there is zero relative motion between them, right? Yet electricity is somehow being generated. But hold on, because it gets so much weirder. Let's jump back to that middle row. We hold the copper disc perfectly still, we take the magnet right underneath it, and we spin it as fast as we possibly can. According to everything we know about relative motion, that moving magnetic field should sweep past the stationary copper disc, cut those lines of force, and generate electricity. But look at the outcome. Absolutely zero current flows. Nothing at all. Now, what's really interesting about this slide is the sheer scale of the contradiction here. Just look at the left side versus the right side. On the left, our core expectation tells us that relative motion is king. If spinning the disk over a still magnet creates power, then surely spinning the magnet under a still disk should do the exact same thing. I mean, it is the exact same relative motion. But on the right side, we see what actually happens in reality. The electrical current completely ignores the physical rotation of the magnet. It's as if the magnet isn't moving at all. And when we spin both the disk and the magnet together, generating current despite there being zero relative motion between the two physical objects, it honestly feels like the physical laws of the universe are just arbitrarily changing the rules on us. Which brings us to Section 2, the false lead. This is exactly where our human intuition completely breaks down. Whenever you encounter a paradox in science, the problem usually isn't with the universe. The universe is functioning perfectly fine. The problem is almost always with us. And the culprit here is a mental shortcut we all take called the simplified flux rule. It's a concept we learn in basic science classes that totally betrays us in this specific scenario. First off, when we picture a magnet, we intuitively imagine those invisible magnetic field lines as if they're physical bristles on a brush, like they are literally glued to the surface of the metal. Because of that first assumption, we immediately make a second huge mistake. We assume that if we physically rotate the chunk of metal, we must automatically be rotating that invisible magnetic field right along with it. And finally, we assume that relative motion applies to invisible, intangible fields the exact same way it applies to solid objects, like cars passing each other on a highway. We treat the invisible field as a solid, glued-on appendage. And guys, that is exactly where our logic falls completely apart. Let's move to section 3 and see how this builds. The big reveal. The invisible field actually sits perfectly still. So, if the field isn't glued to the magnet, then what on earth is it doing while the physical metal is spinning furiously on its axis? Well, let this sink in. The magnet spins. The magnetic field does not. When you have a perfectly symmetrical cylindrical magnet, spinning it on its central axis does absolutely nothing to its magnetic field. The physical atoms of the metal are moving, yes, absolutely. But the invisible magnetic field generated by those atoms is perfectly uniform. It doesn't have a front, it doesn't have a back, it doesn't have ridges or bumps. Therefore, the field itself remains entirely perfectly stationary in space. It completely ignores the fact that the metal generating it is rotating. And this is exactly why, when you hold the copper disc still and spin the magnet, you get zero electricity. The copper disc is sitting in a magnetic field that is not moving. No moving field, no cutting of lines, no electricity. Now, if you're struggling to picture a moving object with a completely stationary presence, think of this analogy. Imagine a perfectly smooth, solid-colored, bright red billiard ball just floating there in space. If it's spinning perfectly on its axis, how would you even know? There are no markings, no scratches, no dots to track. Visually, its presence in space is entirely unchanged by its rotation. A uniform magnetic field works the exact same way. Because it's completely symmetrical, the rotation of the field is physically meaningless. The electrons in the copper disk are looking at that spinning magnetic field, and just like you looking at that solid red ball, they can't feel or detect any change whatsoever. To the electrons, the field is sitting perfectly still. And that brings us to section 4, the true laws of physics. Once we finally let go of our flawed intuition and we stop imagining magnetic fields as glued on bristles, the entire paradox just vanishes. We aren't breaking the laws of physics at all. We just weren't using the right laws. To understand the true mechanics here, we have to look past that simplified high school flux rule and apply something called the Lorentz force. So the crucial point is exactly how this process unfolds. Let's go back to that bizarre scenario where both the disk and the magnet spin together. Why on earth does this create current? Well, step 1, the magnetic field is perfectly uniform, so even though the magnet is spinning, the field is stationary in space. But the copper disk is spinning, so the physical copper disk is actively moving through a stationary magnetic field. Step 2, because the physical copper is moving through that stationary field, the electrons inside the copper experience the Lorentz force, and the Lorentz force dictates that a charge moving through a magnetic field will be pushed sideways. Which leads to step 3, that sideways push forces the electrons to the outer edge of the disk, and a measurable electrical current begins to flow. The relative motion between the physical disk and the physical magnet, it's totally irrelevant. All that actually matters is the motion of the disk relative to the stationary invisible field itself. And this brilliantly illustrates something truly profound about the progress of science. 1831, Michael Faraday actually conducted these experiments and mapped out these rules over a century before we put a man on the moon. And honestly, long before we even fully understood what an electron was. Faraday realized that the field didn't spin, even though it defied literally all the common sense of his era. Yet, almost 200 years later, we still call it the Faraday paradox, because our modern human intuition still trips over the exact same invisible hurdles. Which leaves us with a pretty fascinating final thought to ponder. If our primate brains are so easily tricked by just a simple spinning magnet and a copper disk, if we so completely misunderstand the basic nature of relative motion when invisible forces are involved, what else are we getting wrong? How many other invisible truths about our universe are sitting right in front of us, masquerading as paradoxes, simply waiting for us to stop relying on our everyday intuition and start looking at the actual laws of reality? I really hope this explainer has challenged your perspective today and given you a deeper appreciation for the weird, wonderful mechanics of the physical world. Keep questioning your common sense, keep looking for that hidden logic, and keep learning. Thanks so much for joining me to unpack this fascinating mystery.